Today we'll be doing our lab number 1. That means experiment number 1. The name of the experiment is Introduction to Circuit Simulation using Spice software. That this is there are different version of this software available. Spice means simulation program with integrated circuit emphasis. Okay, here you can see that. I mean, the software we are going to use is Spice. Spice. Okay, it is a light version made by CADS, the leading software manufacturing company or software development company for VLSI, and they are paid software. They're paid. That means you have to buy some. You have to give some money. A paid version of it is more than 20 lakhs. Okay, 20 to 15 to 30 lakhs. One software, 20 lakhs. Understood? Are you getting it? Hello?
Yes, sir.
So one software is more than 20 to 30, 25 lakhs or 30 lakhs. Okay, more than one software only. Remember, see how expensive this software is. Okay, and unfortunately, we do not have it. We do not have it, but I have the light version. Light version means this is a demo. So what is the problem with the light version? Light version problem is that you will face difficulty when the number of transistors become higher. In fact, when the number of transistors is more than 10, you will see that your simulation is no longer running. Okay, when your transistor number is more than 10, you will see your simulation is not running. Got my point? But for learning purposes, this for starting purposes, this is okay. So because in this course we will be just learning about the software, and it is not possible through 1 lab, 2 lab, 3 lab, or even 10 labs to make you understand how cadence work. You have to practice a lot. When whoever is going to get some chance, if you ever get any chance, you will try to learn it thoroughly. Okay, if you ever get any chance. Now here today we will be simulating CMOS inverter. What is a CMOS inverter? What is the schematic? I know, and you know as well. The CMOS inverter is actually a NOT gate, right? A NOT gate. This is a NOT gate. Can you see that? Actually, a NOT gate. If you give V in, your output will be V in bar. All of you know it. And your input, if you give 0, your output will be 1. If you give 1, your output will be 0. You know it as well. Now, this is the circuit. Okay, by the way, this was your logic level circuit. This was your logic level circuit diagram or logic level diagram or schematic. This was your logic level diagram. Now, what is logic level? Logic level means level. I can ask you this in your Viva question. Remember, what is logic level? Logic level means gate level. And this one is the switch level circuit or switch level diagram. What is switch level? Switch level means simplified transistor level. Simplified transistor level. Okay. So what do we mean by that? We mean by this diagram. Here you have one transistor, that means your PMOS. You have one transistor, there is your NMOS. So PMOS and NMOS, their gate is connected and their drain is connected. Gate is commonly called your input, drain is commonly called your output. The upper source is the VDD, the lower source is the ground. And the PMOS is called pull up transistor. PMOS is called pull up transistor, MPU. M means MOSFET, PU means pull up. Why it is called pull up transistor? Because as we know, this is your output pattern, right? When you will get 1 and when you will get 0. Can anyone explain? You know it already. I believe you all. So let me tell you that when a current comes from the VDD and goes through the capacitor, you will get 1, right? So
yes,
for
sir.
getting 1, which transistor is on? For getting 1, which transistors have to be on? Transistor has to be on. PMOS, right?
Yes,
If
sir.
PMOS
Yes,
is
sir.
on, we'll get 1. Okay, fine. Next one. For getting 0, this should be off. This charge should go to the ground, right? So for getting 0, which transistor has to be on? Which one?
NMOS.
NMOS. So here there's one interesting fact. When your output was 0, to make it 1, you need to pull it up to 1, right? You need to pull this thing up here. Which will pull it up? PMOS will pull it up, because if PMOS is on, this 0 will become 1, right? That's why it is called pull up transistor, because it will pull up your 0 to 1. Then why it is called pull down? When it is 1, you want to make it 0, right? You want to pull it down. You want to pull this thing down. So who will pull it down? Your NMOS will pull it down. That's why it is called pull down transistor. Or in other way, whichever the transistor is at the upper position, that is called pull up. Whichever is designed at the down position, that is called pull down. That's it. Now this is called pull up, this is called pull down. That's it. Okay. Now here you have a capacitor, load, CL, because LED is not an option. LED inside the integrated circuit, you cannot put any LED. Rather, you can put an capacitor, load capacitor, CL. So this is your switch level circuit. Now come to the circuit level diagram. What do you mean by circuit level diagram? Circuit level diagram actually means detailed transistor level, not simplified. Detailed. Okay. Here you can see what is the difference. The difference between the previous circuit. The body is here, right? Or substrate. The substrate is connected. Okay. Now in 99% cases, you will see that your body or substrate is connected to the source internally. Internally, your body is connected to the source. Your body is connected to the source. Remember that. Now, what you have to do in this lab, you have to take this circuit and you have to convert the circuit into a code. Okay, into a code. Okay, what code? This code. Okay, you have to convert the circuit into this code. Okay, so how to convert that into a code? There are many rules. As you can see, you can read it by yourself if you want to, but I do not want to read it now. You will read it by yourself. This is some guideline. Here some guidelines are given. What I am going to do, I'm going to write the code in front of you, okay, so that you can understand. Now before writing the code, you have to do one thing. Okay, at first I'm definitely I'm not going to write it in front of you. I'm going to copy it from here, and then I'm going to show you how to write it. Let's copy. I'm going to copy it. Okay. Okay. Now I'm going to go and create a new text document, not Word, not Microsoft Word, not busy or not anything else. Text document, TXT. Text document. I'm going to in the desktop and I'm going to click the text document. Okay. I'm clicking the text document. Now here I'm going to write not get. Okay. Not only not. Or you can write PMOS not. Okay. Understood? I'm going to click here and I'm going to paste the font a bit bigger so that you can understand. I'm going to make the font a bit bigger. Okay, I believe all of you can understand now, right? Is it visible? or should I make it even bigger?
Yes, sir, it's fine.
Now here, I'm going to save these text document for further purposes. Now here, what to do from this circuit to this code? Here, you have to understand this. If any line is started with what? With star. If any line is started what? With star, that is a comment line. Comment. That means these lines are not useful. Okay, these are not useful. These are just comment. That means these are not making an impact in your program. But my point, in your simulation, these are what? These are all comment line. Okay, remember, like in your Arduino programming, if you give double bar, you give something like this, right? Those are all comment, right? Remember. So the star line is what? Comment. Star is comment. Here you can see this is also comment. Now, then you have dot. Dot means this is your command. This is called what? Command line. Command. Here you are giving some command. With command. Here options command. Then here you are giving probe command, analysis command, DC analysis command, and simulation command. Okay, these are all. What is plus? Plus means they are added with the previous line. This command is a huge line. That's why there's a plus. Okay, and normally these are actually written in the specification. Normally here in the specification. Now there are some lines. Those do not have any what? Do not have any star. Do not have any dot. Do not have any plus. Those are your specific or description, not a specification. That is your circuit description line. Here your lines, that is circuit description. Here you have one line, that is your circuit description. So these are your circuit description, remember. Okay, so as VLSI or as doing the simulation, your job will be making this circuit description only, because this part, this is your NMOS model. This depends on the semiconductor that you are using. Okay, in your case, it is silicon. This depends on the silicon that you are using. Understood, everyone? This is NMOS. It depends on the doping. It depends on the semiconductor. It depends on the carrier density. It depends on the something else. Got my point? This is not physical. This depends on the material. So you are not going to write. Who will write this? The material engineer in your company. Okay, the material engineer, they will examine the what? Examine the silicon. They will examine the p-type doping, n-type doping, and they will see what is your thickness of oxide, what is your threshold, what is your the permittivity, what is your permeability. So this sort of things they will calculate and they will tell it. Okay, this thing, this material, let's say this is fixed, so you're not going to touch this. Okay, you are going to touch, or you're going to edit this part and okay, only this part. So why you are not going to touch it? Because once you bring one silicon from the market, that is fixed, right? So you cannot do anything else here. So you can, if you want to do some experiment by changing some values, you can, but for now you can fixed. Now here, how to write the circuit description, that should be your concern. The way of writing the circuit description is, at what you have to do, at first you have to draw the circuit, right? Draw the circuit. Second, you have to what? You have to name it. Name means what? This one, this input is called V in. This output is called V out. This voltage is VDD. As you can see, all the voltages are starting with V, right? Your input is a voltage, that's why it is V. Your power is voltage, that's why it is V. Your output is a voltage, that's why it is V. Remember, all the voltages will start with V. Then you can write VA, VB, VO, VB, Vx, V blah, whatever you think. Okay, but V should be there. V means this is a voltage. Okay, fine. Next, you have to go and name the MOSFETs. If you have to start with M. Remember, M. M means MOSFET. This is MPU. This is MPD. This is MPU means M pull up. MPD means M pull down. You can write something else as well. You can write, let's say, MP. That means the P MOSFET. You can write MN. That means N MOSFET. Whatever you want. Or you can write M1. This is called M2. Whatever you want. Doesn't matter. But M should be there. Next, what have you? Oh, you have a capacitor. So capacitor starts with C. Remember, C. You can write CL like this, CL. You can write C load. You can write C1. Okay, whatever you wish, but C should be there at the beginning. There is a list at the top. For resistor, the R should be there. For inductor, what? Something else should be there. So these are the things you have to maintain. Because if you do not maintain this first letter, the software will not understand whether it is a voltage or it is a current, it is a MOSFET, it is a resistor, it is a capacitor, it will not understand. Okay? So you have to maintain. It's called naming. Oh, then you have to write the name as well. Which one is gate, which one is drain, which one is source, which one is body. You have to write this name as well. Understood, everyone?
Yes, sir.
Okay. Next, you have to what? You have to write the node. Maintain this sequence. First draw, then name, then node. Node means you have to do some noding. Nodal in your semester 2 or semester 3, maybe I forgot. You have done a analysis called nodal analysis. Nodal in your electrical DC circuit.
These are
Yes,
nodal
sir.
analysis local analysis.
Exactly. What you have done there? তুমি কি করছিলা?
Not, sir.
No, but what is the process? If I give you a circuit, what is the process?
Okay, sir. We try.
কাদের মনে আছে? So if I give you a circuit, you have to give some nodes, right? You have to define some nodes. What is the nodes? Nodes means point. You have to give some points, right? So let's see. Point number 1, you have to give 0 to ground nodes. Wherever the ground you have, that is 0. Okay. So here you can see you have one node here. This is 0. This is 0. And since this body is connected to this source, so this is 0 as well. Understood? And one more thing. And since your VDD is a voltage source, right? If VDD is a voltage source, so the other point of the VDD is also what? It is also connected to the ground. Your input is also a voltage, right? So this has an input. Let's say this is a pulse. The other point of this input is also what? Connected to the ground. So this is your node 0. This is what? Your node 0. Understood, everyone? What is node 0? Node 0 means whatever the things that is connected with 0, that is your node. That is connected to the ground, that is your node 0. Now, after the node 0, go to the inputs. Okay? Go to the inputs. Understood? Inputs means you have to define the inputs now. Let's define the inputs. Wait a second. after giving the 0, you have to go for the inputs. If you have one input, definitely that is what? Definitely that is 1, right? If you have two input, after that 2, 3, 4, something like that. Now here, which one is 1? Think about this. Your 1 is from this point to this point, then to the gate, or here as well, right? So up to this is your 1. Now, do you have any more inputs? No, I believe you do not have any more inputs. So now go for the other nodes. Here from the top, you have an input called 2. You have a node called 2. That is your VDD. So which one is VDD? From this point to this point is your VDD, and source is connected with the body. So this is also your VDD, right? This is also your node number 2. Now, else you have something here, right? Your drain is connected, your capacitor is connected, your output is connected. So this wire is your node number 3. So let's make this pink. This is your node number 3. So the whole wire is your node number 3. So all the points of the circuit is covered, right? Right, everyone?
Yes.
Hello. So all the points are covered. Now, so your noding is done. After the noding, you should do what? You should do the coding, right? Draw, node, code. You have to do the code, right? How to do the code? Now let me get into that. To write the code, what do you have to do? At first, you have to define all the Mosfets. So how many Mosfets do you have here? Please talk to me. Mosfet do you have here?
2, sir.
2. So one is called MPU, another is called MPD. That's why I have written MPU PD. Understood? Now what is MPU? MPU is this one. After that, you have some numbers, right? MPU space number space number space. So what are these numbers? These numbers are your nodes around this MPU. Around the MPU, these are your nodes. Okay. What is the sequence of the node? Drain, gate, source, drain, gate, source, body. Remember this. Remember this. Drain, gate, source, body. This is the sequence. DGSB. Oh, I made a mistake. Drain, gate, source, body. This is the sequence. So what is the drain? What is the drain of MPU? Where it is connected? Where it is connected? Drain. See this. See this. This one. What is the drain? What is the color of the drain? Purple, right?
Yes, sir.
Yes.
Purple means 3, right? That's why it is 3. What is the color of the gate? What is the
1.
color?
Blue.
Blue. That means 1, right? What is the color of the source?
Red.
Red, right?
Yes, yes, sir.
It is 2. And what is the color of the substrate? It's also
Also
2.
red. Yes.
Also red, also 2. So 3. Understood this?
Yes,
Okay,
sir.
now. Next, you have to give a space. Then you have to specify whether it is P type or N type. What is this gate? P type or N type? So
Then
that's
P
why
type.
you have to write PENH. Then you have to give a space. Then you have to write the width and the length, right? What is width? What is length? Remember the first PDF,
Sizing.
width and length. It is 13. Here the width is 3. 13 micrometer and L is equal to 3 micrometer. Understood, everyone?
Yes, sir.
What
Yes,
is
sir.
MPD? MPD, let's go for, okay, by the way, today's lab, the objective of today's lab will be finding out perfect value for this 4. Our today's lab will be finding the perfect value for this 4 for element. The element we are using here, for this element, we have to find the perfect values of W and L. That is the only objective of today's lab. Okay? আজকে আমরা কি করব? আজকে আমরা এই এলিমেন্ট গুলোর জন্য কি করব? আমরা আমাদের এই W এবং L এর পারফেক্ট ভ্যালুগুলো বের করার চেষ্টা করব। ওকে, আন্ডারস্টুড? Okay. Remember, I told you that your W and L should be 2:1. For PMOS, it should be 2. For NMOS, it should be 1.
Yes, sir.
And your L should be 1:1.
Yes, sir.
Remember, here, as you can see, your L is 1:1 because it is 3. It is also 3, so 1. But it is not 2:1. Can you see that? So today we will check it. Okay. So it is 4, it is 13. It is not 2:1. It is more 2:1, more than. So we'll check that. Now come to the MPD. Come to the MPD. Now see this, everyone. What is the color of the drain? What is the color of the drain?
Very good.
Purple, right? Sakline বলো তো আজকে কোথায় আমাদের ওই যে নাম কি ছেলেটা হাসানুর কোথায় হাসানুর Where is Maruf? Okay, Sakline তুমি বলো তো যে এটার ড্রেনের কালার কি? আমাদের NPD এটার ড্রেনের কালার কি? বলো তার মানে তুমি ক্লাসে নাই তাই তো
স্যার
তার মানে তুমি ক্লাসে নাই তাই তো
স্যার আমি ক্লাসে আছি স্যার।
Now here see CD your MPD, the color of the drain is purple, right? So it is 3. So 3, the gate is 1, then drain is 0, the source and the body is also 0. Okay, drain, gate, source, body, drain, gate, source, body. Okay, everyone. And since it type, so you have to write NENH. And what is the W? W is equal to 4. What is the L? L is equal to 3. Micro. U means micro. Remember, U means micro. If it is any, you do not have to write anything else. So just 3. 3 is fine. But if it is milli, you have to write small m. If it is micro, you have to write U. If it is nano, you have to write N. If you write P, it is femto, you have to write F. Okay, everyone? Okay?
Sir, to repeat করেন sir.
Yes. This is in micrometer. Micro means U. If it was in milli, you have to write M, small m. If it is nano, N. Pico, P, small p. Femto, small f. If it is meter, that means no nano, no micro, no milli, just nothing. Just a number. Understood?
Yes,
Just
sir.
the number. Okay, now next you have to after the MOSFET you have to explain what? You have to explain the voltages. When your MOSFETs are done, you have to explain the voltages. Now, how many voltages do you have here? How many voltages do you have here? Apart from output. Output বাদে কয়টা ভোল্টেজ আছে এখানে? two voltages.
Inverter, sir.
One is VDD, another one is
V.
VIN, right?
Yes, sir.
So VDD is this one. VDD, because the name is VDD, you can write something else as well, but V should be there. V means voltage. Where it is connected?
So
Where it is
two number
connected?
branch.
Exactly. So 2 and 0, right?
Yes, sir.
Positive 2, that's why it is 2. And ground is 0, that's why it is 0, right? 2 and 0. Understood, everyone?
Yes, sir.
And what is the voltage? What is the value of the voltage? How much volt do you have? How much volt? How much volt?
5 volt.
5 volt. If you want to write DC, you can write 5 DC. But if you do not write DC, it will be DC, right? Because DC voltage is DC voltage has one property only, that is the value of the voltage, that is 5. So if you just write 5, this is a DC voltage. Now the next one, in. So I'm writing V in. If it is VA, you write VA. If it is VB, write VB. If it is VI, write VI. If it is V in, write V in. So where it is connected?
1, 0.
1 and 0, right? And what type of voltage is this?
Pulse.
It is a pulse voltage. Now, here is important. What is this? You have written pulse, but what is this? Now remember this. This one is a what? This one is a what? What should I say? A sequence. What is the sequence means? Okay, let me draw something here. This sequence is like this. At first, you have to write voltage low, then you have to write voltage high, then you have to write delay time, then you have rise time, then you have to time fall time, then you have to write on time, and with pulse width. Okay, understood? On time is, then you have to write period, and T, or total time. You can write total. That is period, total period. So what is the high? What is the lowest voltage you have? Lowest voltage means low level. Since it is a pulse means what? So 0 volt and 5 volt, right? So what is the lowest value? What is the lowest value? 0.
Yes.
5, right? So this one should be 0. This one should be what?
5.
5. Now what is delay time? Delay time means after starting the simulation, it will take some delay, right? Now you cannot make it 0. There should be some delay. You cannot make it 0. So that's why I have written 0.3. And rise time means you're from 0 to 1, it will take some time, right? From 0 to 1, take some what? It will take some time. That is called rise time. So there is a definition for rise time and fall time. You read it by yourself. Rise time formula means it is time taken for a car or for a wave or for a pulse to rise from 10% of the voltage to the 90% of the voltage. Okay, 10% to 90%. If the time requires, that is called the rise time. For fall time, is time required from falling from 90% of the voltage to the 10% of the voltage, that is called fall time. But on other word, you can say this one to this one. Okay, how much requires from 0 to 1? It is from going from 0 to 1. That is called rise time and fall time. Now for this delay time, you cannot make it 0. That's why 0.3. Rise time, you cannot make it 0. It needs some time. So 0.3. Fall time, you cannot make it 0. That's why 0.3. Now the on time, let's say your pulse is like this. Okay, let me delete these. Your on time is this. Okay, this is your on time. Your on time is 20 nanoseconds, and your total time, that means your period, is 40 nanoseconds. So I want it exactly half. So it is 20, it is 40. That means total is 40. So this is also 20. Understood? 20, 20. That's why the total is 40. Understood, everyone? So 0, pulse, 0, 5, 0.3, 0.3, 0.3, 20, and 40. So that is your V in. Now next come here, your final one, your capacitor. This part is your output. For output, you have to define what is your output device or output load. What is your load? Here CL, capacitor, that means a load capacitor is your output device. Here, your output device is connected where? কোথায় connect করা হয়েছে তাকে?
Sir, 3
Exactly,
and
3 and
0.
0, right? So your capacitor is connected to 3 and 0. So 3 is the value of the capacitor. Here in the question, here in the diagram, it is written 50 picofarad, but 50 picofarad is too big. 50 picofarad is too big for this MOSFET. So that's why I have changed it to femtofarad. Okay? 50 picofarad is too big. That's why I changed it to what? Femtofarad. Understood? 50F. That means 50F, small f. Now, I see two types of what? Two types of output. One is called transient output. This one, not this one. Another one is called DC output. Transient analysis, DC analysis. There are three types of output. One is called transient analysis. Another one is called DC analysis. Another one is called AC analysis. We're going to see the transient analysis and DC analysis. AC is not needed for VLSI. Okay, for this lab actually, not VLSI, for this course actually. What is transient? Transient means a graph with respect to time. If your graph is drawn with respect to time, that is called transient graph. Your input is this one, your output is this one. This is called transient graph, okay, with respect to time. This is your input, this is your output. With respect to time. With respect to time means it is called transient. So we want to see transient graph up to how many seconds? Up to 80 seconds, 80 milliseconds. No, not millisecond, 80 nanosecond. Why? Why 80? Because I want to see a graph in 2 cycles. This is 1 cycle. 1 cycle is how much? How much is 1 cycle? Our input. How much is our 1 cycle?
20.
No, 20 is the on and off.
Total 40.
40. So since we want to see 2 cycles, so this is 40. This is another cycle, right? So 80. Understood? So I want to see at least 2 cycles. That's why I have 80 here. If you want to see 3 cycles, you will give 120. Understood? I want to see 2 cycles. That's why I have given 80. What is the
Yes,
first nanosecond? That is after how many seconds I will plot a point. This is the plotting point, okay, axis. So second, take data. 2 milliseconds, take data. 3 milliseconds, take data. 4 milliseconds, take data. So like that, I will go to up to 8 nanoseconds. Okay, that is the plotting value. Now come to the DC analysis. What do you mean by DC analysis? DC analysis is a graph where compare your graph with respect to 2 voltages. Here you will have 1 voltage, here you will have 1 voltage. What voltage they will have? Here I will have input voltage, here I will have output voltage. This is voltage, not time. This is called DC analysis because the DC voltage. So your graph will be like this. Remember this graph? Okay, if you do not remember, I will tell you again. This is the DC analysis graph, but that means the voltage versus voltage. So this is the DC analysis. Here you have to explain What is the axis? X-axis, V in. V in is the x-axis. What limit? 0 volt to 5 volt. That means from here, 0 volt to 5 volt. From here, 0 volt to 5 volt. You have to explain what is the voltage limit and how the voltage will increase. So point 1. So 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, blah, 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 1, 1.1, 1.2, 1.3. Like that. You have 5. Understood?
Yes,
Upper
sir.
point, you have to go up to 5 by the step of 0.1 volt. Then you have to click to write dot probe. Dot probe means it will plot the data. Dot end, it will end the simulation. That's it. So let's code after making the code. So draw name node code. After that, you have to make a circuit file. So after you are done with your writing the code, you have to do one important step. Everyone, look very carefully. I will not tell it again. Go to the file, click not save, click save as in the desktop or wherever you want. I want to save it as a circuit file. At what file? Circuit file. The extension for circuit is .cir, small cir, capital CIR or small cir. Remember, the extension is .cir. So here I have to write CIR or small CIR, whatever you do. Remember, dot. Normally it is a text file, but I am saving it as a circuit file, CIR. Where you have to change the type from the text document to all file. Remember this. So CMOS not .cir, that is the circuit file, and change the type from the text document to all file. So save it. You will see a special type of file is created in your desktop. Can you see that? Can you see that? Okay, that is the circuit file. Now here, I do not have the software installed in my computer because I uninstalled it, and I want you to see how to install it. Okay. Now this one, I have given you all 3 software. This one is already done. This one will be done in subsequent days. This is the software, AllCap Capture Lite. This is the software that we want today, AllCap Capture. Click this folder, click extract to, click voltage desktop, wherever you want to save it. Okay. Let it do it work. Okay, done. Now this is the folder. Now go to the setup. There is a setup file. This one is the setup. Right click, run as admin. Yes. Okay. No problem. Next. Here you have to select all of them. It's not possible. That's why you cannot. So all of this you have to click. If you do not click, it will not work. That's why I want you to see it first. Next, 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 done. Okay. Finish. Not needed. Not needed. Read it. Okay. Okay. So our software is done. If I refresh, oh not. So what is the Spice? As you can see here, I have the Spice folder. All of the softwares are here. What I need the Spice AD. Can you see that? I need this Spice AD Light Edition. Remember, this is the Light Edition. Okay, not the paid one. I told you the paid one is, and the updated one is huge expensive. This one is the paid Light Edition. So I'm clicking the Light Edition. Here, I want to open that circuit file. Okay, clicking the circuit file and opening it here. Understood? I am opening it here. Got my point? Or you can open it by using this button. Open. Now here you have the software. Here you have the file that you have done, circuit file. Now I want to not like that. Double click. Okay. Double click. It will open. Now I want to this. For simulating this, you have to click this button. Okay. You have to click this button. So I'm clicking this button. It will ask for what type of analysis I want to do. I want to do DC or transient. At first, I want to do the DC analysis, not the transient, because I told you before ours to find out the W and L, right? So if I click the DC analysis, here you have nothing. So how to bring something? This button, insert. What is the insert? Trace. You have to click the trace, add trace. There's an insert button, right? In your keyboard, you have a button called insert. Click that button, or you can click add trace, or there is one option here as well. Okay. Either one, if you click trace, ask you what type of simulation data you want to see. I want to see two voltages. One is the output voltage, that means the capacitor voltage, that means the V1CL. Can you see this? V1CL, that means the capacitor voltage, that is our output, remember? And I want to see the V in or V1 V in, whatever, V1 V in or V in, anyone, doesn't matter. So I want to see V1CL and V1 V in. I want to see these two. So I click V1CL, I'm going to click V1 V in. That's it. Click OK. This is your input and output relationship. This one, if I click this graph, right click, you have properties. I can make it bigger. I click this properties, I can make it bigger. The red one is your input. Input means with respect to input. The green one is our output versus input. One in this x-axis you have input, in this y-axis you have output. As you can see, for the perfect design, your output should go for perfect design, your output through the middle. Is it going through the middle? Is it going through the middle?
No.
A bit towards the right side, right? It should go through the middle here, right? For perfect design, it should go through the middle. But it is nearly perfect, but we can make it perfect. How? See, here you have 4 buttons, 4 to 5 buttons. Click the upper one. This is your code. I'm going to change the design from 13. Okay. I want to change from the 13 to 12. Run, save, transit, DC. See, is it perfect now?
Yes,
so what
sir.
is your setting? What is your setting? For PMOS, your W is what? 12 And what is L? 3. What is for NMOS? 4. L is what? Your W for PMOS, your W is 12, and for NMOS it is 4. This is your perfect setup.